Alien worlds and unknown orbits, what we see at the edge of space. Out there, far beyond the reach of our telescopes, beyond the whisper of sunlight, beyond the edge of everything we've ever known, there are worlds we can barely imagine. Planets that never see a dawn, moons that orbit invisible suns, oceans that boil under skies of methane, and perhaps civilizations that evolved in darkness, under alien stars, following laws of nature we have yet to understand. The universe does not end where we stop looking. It only begins. Every night, as the Earth spins through its vast orbit, we are surrounded by billions of worlds, each one a mystery suspended in the silence of space. Yet, for all our exploration, we've only just begun to glimpse what lies at the edge, where gravity grows weak, where light fades, and where the known laws of physics start to fracture. This is where the true story of the cosmos begins, in the orbits that should not exist, in the planets that defy every model we've built, in the stars that seem to have wandered from another universe entirely. Scientists call them rogue worlds, planets not bound to any star, drifting freely through interstellar space, cold, dark, and utterly alone. But some of these wanderers show signs of atmosphere, some heat, some even magnetic fields strong enough to generate auroras, glowing veils of light in the endless dark. How can that be? How can a world without a sun still breathe, still move, still burn? The deeper we look into space, the stranger the answers become. At the edges of our solar system, beyond the frozen debris of Pluto, there may be another planet, a giant world 10 times the mass of Earth, orbiting so far away that 1 year there could last 20,000 of ours. Astronomers call it Planet 9. Yet, no one has seen it. Its gravity is felt, its presence inferred, but its face remains hidden. If such a planet exists, it would rewrite everything we know about the architecture of our solar system. But what if Planet 9 isn't a planet at all? What if it's something else? A remnant of another star system, a captured world, or perhaps even a fragment of dark matter itself. And then there are the exoplanets, thousands of them orbiting distant stars, each with its own impossible story. Some orbit 2 suns, like Tatooine from fiction. Others are covered in liquid metal oceans or made entirely of diamond. Some worlds rain glass sideways in 100-mile-per-hour winds. Others orbit so close to their stars that a single day burns hotter than molten steel. But beyond the beauty, there's something far more haunting: patterns. Worlds that seem to repeat, orbiting in mathematical harmonies. Systems where the distances and ratios of planets follow precise geometric rules, as though written by an ancient cosmic architect. Coincidence? Or could there be a deeper order we've only begun to sense? We are explorers standing at the shore of an infinite ocean. Every signal from deep space, every flicker of dim starlight could be a clue. Not just to what's out there, but to who we are. Because to look into the cosmos is to look into a mirror older than time. At the edge of space, discovery and mystery are one and the same. What we find challenges everything we believe about life, time, and destiny. Stay until the end, because what we're about to uncover may change the way you see the universe, and your place in it, forever. If this story has already pulled you beyond the edge of what's known, then you belong here, among those who still look up and wonder. Subscribe, not for answers, but for the questions that remind us how vast we truly are. Share this journey with someone who still believes that Earth is only the beginning. Because the more of us who look into the dark, the brighter the universe becomes. Rogue planets, the nomads of the cosmos. Imagine a planet drifting through space without a star. No sunrise, no orbit, no home. Only eternal night stretching in every direction. These are the rogue planets, the cosmic nomads. Worlds unanchored to any sun, wandering silently between the stars. For decades, astronomers believed such planets were rare, strange outliers lost to the gravity of dying systems. But recent surveys tell a different story. There may be billions of them. In fact, they could outnumber the stars themselves, each one a dark, frozen world, an orphan of cosmic violence, ejected from its birthplace when gravitational forces between giant planets turned chaotic. In those brief moments of instability, entire worlds were flung into the void, cast away forever. And yet, not all rogue planets are dead. Some are massive enough to retain internal heat, glowing faintly in the infrared. Their cores still churn, generating warmth and storms in the absence of sunlight. Others may host thick atmospheres that trap geothermal energy, keeping their surfaces warm enough for oceans, hidden beneath miles of ice. A few could even carry life, thriving in the dark, powered not by starlight but by chemistry and pressure. If such life exists, it would be utterly alien. Creatures evolved without day or night, without seasons, without sight. They would navigate their world through sound, vibration, or electromagnetic pulses. To them, light itself would be myth. Astronomers detect rogue planets not by sight but by shadow. When one drifts in front of a distant star, its gravity slightly bends the starlight behind it, a phenomenon called gravitational microlensing. In those brief flashes, lasting only seconds, a hidden world reveals itself before vanishing again into the dark. These events are so rare and fleeting that catching one feels like witnessing a ghost. And there are other clues. Some rogue planets, massive and young, still radiate heat from their formation. The WISE and Spitzer space telescopes have detected a few of these faint embers drifting between constellations, each one a silent testament to the universe's power to create and to exile. But there's an even deeper mystery. Some rogue planets appear too stable, too intact, to be the products of violent ejection. Their orbits through interstellar space suggest they may have formed alone, without ever belonging to a star system. If true, this means planets can emerge in the darkness itself, born not from the debris of a sun, but from collapsing clouds of gas in the galactic void. Such planets challenge everything we know about creation. In a universe built around stars, they are the exceptions that rewrite the rule. If they are numerous, and evidence suggests they are, then the galaxy is far stranger than we imagined. Between the stars lies not empty space, but a hidden wilderness of worlds, cold, silent, unseen. And here's the thought that lingers. If rogue planets can sustain warmth and possibly life, then the story of existence may not be confined to sunlight at all. Life could have begun in the dark, long before stars ever formed. In the vast, unlit corridors of space, evolution may have found another path, one that thrives without light, one that survives where we would freeze. We often say life requires a star, but maybe it only requires persistence, a will to endure in the cold. If so, then somewhere, drifting between galaxies, there may be oceans beneath frozen shells, pulsing with creatures that will never see a sunrise, yet live within an eternal night that never truly ends. These are not dead worlds. They are reminders that existence finds a way, even in the most impossible places. The hidden symphony of alien orbits. When astronomers began charting exoplanets, worlds beyond our solar system, they expected chaos, random distances, unstable orbits, planets scattered by the violence of creation. Instead, what they found was something astonishing: order. Subtle, mathematical harmony written into the movements of alien worlds. Across the galaxy, entire systems of planets orbit their stars in rhythms so precise they resemble the structure of music. In some systems, planets move in resonance chains, orbital ratios of 2-1, 3-2, 4-3, locked together by gravity in elegant synchrony. When one completes 2 orbits, another completes exactly 1. Their gravitational pulls keep them balanced, like instruments playing in tune. The TRAPPIST-1 system is a perfect example. 7 Earth-sized planets circle a dim red star, each orbiting in near-perfect harmony. If you could hear their movements as sound, they would form a cosmic chord, a melody resonating across light years. The pattern is so exact that if one planet shifted, the rest would eventually collapse into chaos. Yet they don't. They dance together in mathematical perfection, as if following a hidden score. How does such precision arise from the randomness of gravity? Some scientists believe that as these systems formed, planets migrated through their disks of gas and dust, locking into resonant orbits like dancers finding rhythm in turbulence. Others suspect that this harmony might reveal something deeper, a self-organizing principle within nature itself, a tendency toward balance woven into the laws of physics. But not all orbits are serene. Some are elliptical, stretched to extremes, carrying planets close to their stars before slinging them far into the cold. These worlds live violent lives. Their skies flash between inferno and ice. Oceans boil and freeze in endless cycles. The forces that sculpt their paths are ancient and merciless, gravitational battles between giants that never truly end. Then there are hot Jupiters, gas giants orbiting impossibly close to their suns, so close that a single year lasts only a few days. Some of them are tidally locked, one side eternally scorched, the other trapped in endless night. For years, astronomers couldn't explain how such massive worlds could exist in those positions. Now, they believe these planets were born farther out and migrated inward, spiraling toward their stars until they found a fragile balance on the edge of destruction. Still others orbit two stars at once, their skies filled with twin suns, one rising as the other sets. These circumbinary planets were once thought impossible, yet they exist. The delicate gravitational harmony required for stability is so fine that the smallest disturbance could tear them apart. But nature finds a way. Even here, in the most precarious conditions, order emerges. The deeper we map the galaxy, the more we see that these patterns, these cosmic harmonies, repeat. Systems light years apart seem to follow similar ratios, similar geometries, as though guided by a universal template. Is it coincidence or evidence of an underlying code? Some physicists wonder if the universe itself is a kind of simulation, governed by mathematical laws so elegant that planets and stars naturally fall into patterns of symmetry. Others see something more profound, a kind of cosmic intelligence expressed through physics, a balance between chaos and order that defines existence itself. In every system, we see a reflection of our own, a fragile orchestra held together by invisible forces, each world moving in time with the rest. We call it mechanics. But it feels like music. Perhaps gravity isn't just the force that binds the cosmos. Perhaps it's the rhythm that gives the universe form. The orbits of alien worlds are not random accidents. They are evidence that even amid the vastness there is structure, intention, and beauty. And if such harmony exists everywhere we look, what might it reveal about where we came from and where we're going next? Worlds that shouldn't exist. There are planets in our galaxy that defy every model of creation. Worlds so extreme, so improbable, that their very existence forces science to question its foundations. They are the cosmic anomalies, the worlds that shouldn't exist. Take WASP 76b, for instance, a planet where it rains molten iron. Locked in eternal day and night, one side faces its star in unending fire, while the other freezes in perpetual shadow. The temperature difference is so great that metals vaporize on the hot side, drift through the atmosphere, and condense as iron rain on the dark side. No theory predicted such a world. It shouldn't be stable. Yet there it is, glimmering in the void. Or Kepler 10b, a planet so close to its star that its surface is likely an ocean of lava. 1 year there lasts less than a single Earth day. The gravitational tides stretch it like a heartbeat, deforming its surface as it endlessly burns. How could such a world survive without being torn apart? No one knows. Then there are super-Earths, rocky planets far larger and heavier than ours. According to early models, such planets shouldn't form in stable orbits close to their stars. Yet they're everywhere. Their density and mass place them between Earth and Neptune, occupying a range of possibilities nature was never expected to create. Some may be covered in deep global oceans. Others could be diamond worlds, forged from carbon under immense pressure. Even more confounding are ultra-hot Jupiters, gas giants that orbit so close to their suns they should evaporate. Instead, they maintain vast atmospheres of metallic hydrogen, with winds faster than sound. The radiation they endure would sterilize any known material, yet somehow they endure, defying both physics and logic. Farther out, we find another kind of impossibility: planets orbiting dead stars. Around pulsars, neutron stars left behind after supernova explosions, astronomers have discovered worlds that survived the blast. Some may even have formed from the remains of those cataclysmic deaths, coalescing from the ashes of destruction. These are worlds born from chaos, circling corpses that still emit deadly beams of radiation across the cosmos. They should not exist, but they do. And then, there are the mirror worlds, planets that appear almost identical to Earth in size, density, and orbit, yet seem fundamentally different. Some orbit in reverse, retrograde paths that defy the rotational direction of their stars. Others tilt at impossible angles or spin so fast their equators bulge outward. The more we find, the more it seems that our solar system, once thought typical, may be the true anomaly. Even the concept of habitability itself is being rewritten. Once we believed life could only exist within a narrow Goldilocks zone where water can remain liquid. But discoveries like Kepler 452b and Gliese 581g suggest the boundaries are far wider than we imagined. Some worlds orbit cool red dwarfs and still show signs of atmospheric balance. Others orbit binary stars, experiencing perpetual dusk, yet maintaining climates that could, in theory, sustain life. Each discovery pushes the question further. Is the universe obeying laws we've yet to understand, or are we simply glimpsing the infinite creativity of nature? Every impossible world reminds us that our models are not rules. They're maps, drawn too early, of a territory far larger than we imagined. The more we search, the more the cosmos teaches us humility. For every planet that fits our equations, there's another that shatters them. What we once thought impossible turns out to be inevitable. Maybe impossibility is not a boundary of nature, but a limit of human perception. And if these worlds that shouldn't exist do, what other impossibilities might await, not just out there, but closer than we think? The planet at the edge of the solar system. Beyond Neptune's frozen orbit lies a realm where sunlight fades into darkness, a region known as the Kuiper Belt, filled with ancient ice and the remnants of planetary creation. For decades, astronomers believed that Pluto was the last world of our system. But in recent years, something strange has appeared at the edge of the solar system, a gravitational whisper that refuses to be ignored. Tiny icy bodies beyond Pluto, known as trans-Neptunian objects, seem to orbit in a curious alignment. Their paths are tilted, elongated, and mysteriously synchronized, as if pulled by an unseen hand. This pattern is too precise to be coincidence. Something massive is out there, bending their orbits, shaping their motion, yet remaining completely invisible. The evidence points to an object 10 times the mass of Earth, orbiting perhaps 20 times farther from the Sun than Neptune. If real, this planet would take between 10 and 20,000 Earth years to complete a single orbit. Astronomers have named it Planet 9, a world that could redefine everything we know about our solar system's architecture. But no one has ever seen it. Telescopes have scoured the sky where its gravity should place it and found nothing. Some say it hides in the farthest shadows, too faint for our instruments. Others think it might not be a planet at all. One theory suggests that Planet 9 could be a captured rogue planet, a wanderer from another star system that was pulled into our sun's gravitational field billions of years ago. If true, then our solar system is not a closed family, but an open gate, one that occasionally captures travelers from the dark. Another, more radical idea proposes that Planet 9 might not be made of rock or gas at all, but of dark matter, the invisible substance that makes up most of the universe's mass. If such an object exists, it could be a tiny clump of that mysterious material, exerting gravity but emitting no light. It would be a ghost planet, unseen but powerful, shaping orbits from the shadows. Still others wonder whether Planet 9 even exists. Perhaps the strange orbits of those icy bodies are not the result of an object at all, but the collective pull of thousands of smaller ones, an unseen swarm of frozen worlds acting together as one. In this view, the planet is an illusion created by chaos itself, yet the mystery deepens. Some researchers believe that if Planet 9 is real, it could explain one of the oldest puzzles in astronomy, the tilt of the solar system itself. The plane of the planets is slightly skewed compared to the Sun's equator, as if the entire system were subtly off balance. A massive, unseen planet tugging from afar could account for that tilt, its distant gravity shaping our cosmic alignment from the dark. The search continues. Powerful observatories like the Vera C. Rubin Observatory in Chile may soon scan deep enough to detect faint traces of this hidden world, a slow, cold light moving against the backdrop of stars. If we find it, it will be the most distant planet ever known, orbiting in a realm where no sunlight reaches, where time itself seems to slow. If we don't find it, the mystery only grows, because something out there is pulling the strings, something vast, invisible, and ancient. The edge of the solar system is not the end, it's the threshold. Beyond it, the familiar laws of our cosmic home begin to blur. The space between stars is not empty, it's alive with gravity, memory, and motion. Perhaps Planet 9 isn't just a world, but a reminder that even here, in our own backyard, the universe still keeps secrets we can barely begin to comprehend. The sky of two suns. For most of human history, we imagined our sky as ordinary. One star, one sun, one center of warmth and gravity. But in the grand theater of the cosmos, our single-star system is the exception, not the rule. The majority of stars in the Milky Way are binaries, pairs locked in eternal orbit, each circling the other in a delicate gravitational dance. Some are close enough to share their outer layers. Others are separated by billions of kilometers, bound only by the faintest pull of attraction. And around many of these twin suns, new worlds are born. These are the circumbinary planets, worlds that orbit not one star, but two. They are the real-life versions of the imagined landscapes of fiction, like the famous twin sunset of Tatooine. Yet these are not just cinematic illusions. They are real, physical worlds, their skies painted with light from two suns that rise and fall in tandem. To exist in such a system is to live in perpetual motion. The light, gravity, and heat shift in patterns that no Earth-born mind could easily grasp. On some worlds, the suns might orbit so closely that they appear as a single blinding sphere, a constant brilliance that never dims. On others, the stars drift apart and converge again, turning day into twilight, twilight into night, then night back into fire. Seasons would not be measured in months, but in alignments. The discovery of these worlds shattered what astronomers once thought possible. For decades, they believed that the gravitational tug-of-war between two stars would make planetary orbits unstable. Yet we now know that stability can emerge from chaos. Worlds like Kepler 16b, Kepler 34b, and Kepler 47c orbit their binary suns with perfect precision, their motion choreographed by the same physics that threaten to destroy them. In the skies of Kepler 16b, two shadows fall on the ground, one cast by each sun. Days can stretch for weeks, and nights are rare. The temperature swings are immense, yet balanced, sustained by the dual heat that envelops the planet in cycles of shifting light. To live there would be to experience time differently, not as the steady rhythm of one sun, but as a dynamic, unpredictable harmony. The light itself would pulse through existence like a cosmic heartbeat. Life, if it evolved in such a world, would adapt to dual suns and double tides, its biology tuned to shifting patterns of energy. Some circumbinary worlds may even occupy habitable zones where the combined warmth of two stars keeps water liquid. Others orbit too far, cast into freezing night between flashes of brilliance. The diversity is staggering, not just of conditions, but of possibilities. The implications reach beyond astronomy. The very existence of these planets challenges our sense of cosmic normalcy. If twin sun worlds are common, then the environments capable of supporting life are far more varied than we ever imagined. Perhaps intelligence arises not only under stable, solitary stars like ours, but also amid chaos, on worlds of shifting light, where adaptation is constant and survival demands creativity. There is poetry in that idea, that the same forces that create instability also create beauty. That gravity, the most basic of cosmic forces, is not a constraint, but a composer. It weaves together systems of unimaginable complexity and harmony. It turns what should be impossible into the inevitable. If you stood on the surface of one of these worlds, you would see your shadow split in two. You would watch the horizon blaze twice, your sky painted in gold and crimson as two suns sink into the same sea. And as night finally fell, it would not be dark, because one of them would still linger, glowing faintly beyond the clouds, refusing to disappear. Two suns, two hearts of gravity, two flames keeping watch in an infinite night. The planet made of diamond. There are worlds out there so strange, so breathtaking, that they sound like poetry disguised as physics. One of them orbits a pulsar, the corpse of a long-dead star, and its surface may shimmer with a brilliance that no sunrise could match. Astronomers call it PSR J1719-1438b, but to most, it's known by a simpler name, the Diamond Planet. This world is unlike anything in our solar system. It orbits a neutron star, a remnant so dense that a teaspoon of its matter would weigh billions of tons. Around it, this planet circles once every 2 hours and 10 minutes, closer than Mercury is to the Sun. Yet it isn't destroyed. Somehow it endures. And based on its density, scientists believe that most of it, perhaps all of it, is crystallized carbon. In other words, this entire planet may be made of diamond. To understand how such a world could exist, we must first understand death, the death of stars. When a massive star burns through its fuel, it collapses in on itself, triggering a supernova. But smaller stars like our sun die more quietly. They shed their outer layers and leave behind white dwarfs, compact, cooling cores of carbon and oxygen. Over billions of years, those cores can crystallize. If such a star were stripped even further, torn by the gravity of a nearby neutron star, what remains could condense into something solid, something dazzling, a diamond world orbiting the ghost of its parent. That is the likely story of PSR J1719-1438b. What was once a living star is now a planet, transformed by gravity into crystal. The light it reflects is not sunlight, but the pale radiation of the pulsar it orbits, a flickering beacon that flashes like a cosmic heartbeat. Every rotation sends a pulse of energy sweeping across space, marking the passage of time with eerie precision. But this planet is not unique. Astronomers have found hints of other carbon-rich worlds, formed in the dense regions around ancient stars. One, known as 55 Cancri A, may also be a world of diamond, twice the size of Earth, orbiting so close to its star that its surface glows with heat. Beneath its fiery crust, immense pressure could have turned vast portions of its mantle into pure crystalline carbon. Imagine standing there, if such a thing were possible, beneath skies lit by a white-hot sun, your feet sinking into molten graphite that slowly cools into glittering plains. Every rock would sparkle faintly. Every mountain would shine. It would be a landscape both infernal and divine, beauty born from unimaginable violence. The discovery of these diamond worlds tells us something profound about the universe. That destruction and creation are not opposites, but partners. When stars die, they don't simply vanish. Their remains become the building blocks of new worlds, worlds that, in their silence, still carry the memory of light. Perhaps in some distant corner of the galaxy, there are planets we have yet to see, jewels drifting through the dark, their cores still glowing with the energy of lost suns. They remind us that even in death, the universe creates wonders, that even the end of a star can give birth to something exquisite. It's easy to forget that the atoms in our own bodies were forged in similar furnaces, that the carbon in our cells once belonged to long-dead stars. In a way, we too are made of stardust and diamond, walking reflections of the cosmos itself. So when we look up and see the stars glittering against the night, we're not just looking at the universe, we're looking at ourselves, and at the possibility that somewhere, orbiting in eternal shadow, a world of pure diamond still remembers the light that made it. Oceans in the dark. For most of human history, we believed life required sunlight, that warmth and light were the essential conditions for survival. But in the last few decades, both science and discovery have rewritten that story. Life, it turns out, can emerge in the most unexpected places, not under blue skies, but in oceans of darkness where no ray of light has ever reached. The first clues came not from the stars, but from the depths of our own planet. In the pitch-black trenches of Earth's oceans, thousands of meters below the surface, scientists discovered entire ecosystems thriving around hydrothermal vents, cracks in the seafloor where heat and minerals pour from within the Earth. Here, life does not feed on sunlight, but on chemistry. Bacteria harness energy directly from the planet's heat and metals, forming the foundation of food chains that flourish in eternal night. This discovery changed everything. If life could exist here, without the sun, without photosynthesis, surrounded by crushing pressure and boiling water, then perhaps it could exist elsewhere too. Somewhere far colder, somewhere far darker. Now, astronomers believe that ocean worlds may be among the most common types of planets in the galaxy. These are worlds covered entirely by water or encased in thick ice that hides vast oceans below. In our own solar system, moons like Europa, Enceladus, and Titan have become prime candidates for alien life. Beneath their icy crusts lie global seas kept liquid not by sunlight, but by tidal flexing, the gravitational squeezing and heating caused by their parent planets. Probes have detected plumes of water vapor erupting from Europa and Enceladus, jetting hundreds of kilometers into space. Inside those plumes, instruments have found traces of organic molecules, the raw ingredients of life. If microorganisms exist beneath their frozen shells, they could resemble the vent-dwelling species on Earth. Tiny, resilient, and ancient, living in darkness illuminated only by the faint glow of hydrothermal energy. These oceans are more than laboratories for potential life. They are reminders that the universe's creativity is boundless. Even where light cannot go, warmth and complexity still arise. A planet need not orbit within the habitable zone of a star to sustain life. It only needs energy, chemistry, and time. In the silence between worlds, the conditions for existence may be quietly thriving. And what lies beyond our system may be even stranger. Astronomers have identified water-rich exoplanets orbiting far from their stars, super Europas, with oceans hundreds of kilometers deep. Some may have high-pressure ices at their cores, while others could conceal layers of exotic materials, ammonia seas, methane lakes, or silicate rain. On these worlds, life could take forms unimaginable to us. Not carbon-based, perhaps not even molecular in the ways we understand. In such places, evolution might proceed at a slower rhythm, not measured in years but in cycles of heat and chemical reaction. Consciousness, if it ever arises, would have no sky, no stars, no concept of day or night. It would know only the rhythm of the tides, the pulse of the planet, the echo of thermal currents whispering through an infinite sea. If that sounds alien, it's because it is. Yet it may also be familiar. Because Earth too began in darkness, beneath oceans heated by a young planet's fire, long before sunlight reached the surface. Perhaps every world begins this way, in silence, in shadow, in the dark before dawn. When we look for life beyond our world, we often point our telescopes toward light. But maybe the universe's most enduring forms of life exist in the places where light has never been, hidden beneath frozen oceans, dreaming in the dark. And perhaps one day when our probes finally pierce that ice and touch the sea below, we won't just find alien life. We'll find a reflection of our own beginnings, a reminder that every living thing, no matter how far it drifts from the sun, is born from the same cosmic ocean. The architects of the void. The more we explore space, the more it begins to feel like a paradox, an ocean of matter suspended in an even greater sea of emptiness. Between galaxies lies a vast silence, a cosmic desert so immense that light itself can spend billions of years crossing it. And yet, this void is not truly empty. It has structure, it has rhythm, it has architects. When astronomers mapped the positions of hundreds of thousands of galaxies, they expected chaos, a random scatter of points expanding in all directions. What they found instead was a cosmic web, an intricate network of filaments and clusters woven together like veins of light. Between these threads stretch enormous voids, some hundreds of millions of light years across, nearly devoid of galaxies. The universe, it turns out, is not uniform. It's sculpted, a three-dimensional structure more like coral than chaos. These filaments are made of dark matter, the invisible substance that shapes everything we see. Though it cannot be observed directly, dark matter's gravity sculpts the motion of galaxies, anchoring them like beads along invisible strings. Every galaxy, every star, every planet is built upon this unseen scaffolding. Without dark matter, there would be no cosmic architecture, only chaos. But what are these filaments really? Simulations suggest they are rivers of invisible gravity, channels where matter flows and gathers. They may even connect galaxies across the universe like neural pathways in a brain. If the cosmos has consciousness, this web might be its anatomy. The voids between these structures are just as important. Within them, gravity is weak, expansion dominates, and matter drifts apart like fading echoes. Some theorists call them the cosmic lungs, regions where the universe exhales, releasing energy back into balance. Others suspect that within those immense, near-empty spaces, new physics might be hiding, phenomena that cannot exist in crowded regions of matter. Dark energy, the mysterious force accelerating cosmic expansion, may also originate from the geometry of these voids. Some physicists believe it isn't a separate substance at all, but an emergent property of space itself, a kind of tension in the cosmic fabric, growing stronger as galaxies drift farther apart. The universe might not be expanding into emptiness. The void might be the engine of expansion. And then there's the question no one can yet answer. Why this architecture? Why a universe of filaments and gaps, of luminous threads surrounding cosmic hollows? Is it simply gravity and chance? Or does the pattern reveal a deeper principle, a hidden symmetry shaping all things? The structure of the universe resembles that of neurons, weather systems, and even social networks. Different scales, same geometry. Could it be that the cosmos organizes itself by universal laws of connectivity, reflecting the same patterns across matter, life, and thought? The architects of the void, if we can call them that, are not beings but forces: gravity, expansion, entropy, and time. Together they sculpt the infinite, drawing light into order and returning it to shadow. The galaxies are the visible signature of that work, but the masterpiece is invisible. To stare into the cosmic web is to glimpse the framework of reality itself, a map not just of where things are, but of why they exist in that arrangement. The balance of density and emptiness gives rise to complexity. Too much matter, and the universe collapses. Too little, and it never forms. It is in the tension between presence and absence that the cosmos becomes alive. Perhaps this is the greatest secret of all, that creation and emptiness are not opposites. They are collaborators. The void is not nothing. It's the space that allows everything else to be. The architects of the universe are not building within emptiness, they are building from it. And when we look into the dark between the stars, we are not staring into nothingness. We are witnessing the quiet intelligence of the cosmos, the hidden design that has been shaping us since the beginning. The edge of light. Light is the storyteller of the universe. Every beam that reaches our eyes, every photon captured by our telescopes, carries with it the memory of where it came from, the birth of stars, the collision of galaxies, the echo of the Big Bang itself. Through light, we see the past written across the sky. But even light has limits. And at those limits lies one of the deepest mysteries in all of science. What happens when light can no longer move forward? At the edge of light, time begins to fracture. The speed of light, 299,792 kilometers per second, is not just fast, it's the universe's ultimate boundary. Nothing with mass can surpass it, and nothing can carry information faster. But this constant speed also defines the limits of our perception. When we look farther into space, we look further into the past. Eventually, we reach a horizon, a distance so vast that light from beyond it will never reach us. Beyond that horizon, the universe continues, but it is forever unseen. Astronomers call this the cosmic light horizon, the boundary between the visible and the unknowable. Beyond it lies a universe that has slipped beyond communication, expanding faster than light can travel. Every second, more galaxies cross that threshold, vanishing not because they cease to exist, but because their light will never reach us again. It is not destruction. It is separation. A quiet drifting into the infinite. Even within our own universe, there are smaller edges of light, places where it bends, halts, or dies. Near a black hole, gravity distorts space-time so intensely that light can no longer escape. The event horizon is a place where light stands still, where information itself becomes trapped. To an outside observer, anything crossing that boundary appears frozen in time, forever suspended at the edge of darkness. And yet, paradoxically, light still finds a way to reveal what's hidden. As black holes consume matter, they release bursts of radiation, X-rays, gamma rays, and jets of pure energy that stretch across thousands of light years. These luminous storms mark the frontier between being and oblivion. The edge of light is not the end, it's transformation. In the early universe, long before stars ignited, light didn't exist in the form we know. The cosmos was an opaque fog of plasma, so dense that photons could not travel freely. Only when the universe cooled, about 380,000 years after the Big Bang, did light finally break free. That first light still travels today, stretched and softened by expansion. We call it the cosmic microwave background, and it is the oldest image in existence, a snapshot of the universe's awakening. But even that ancient glow is not the beginning. Before it, there was darkness, a silence deeper than night. In that silence, gravity and quantum fluctuations sculpted the seeds of every galaxy, every star, every world to come. Light didn't create the universe, it revealed it. At the edge of light, science meets philosophy. Because every time we build a more powerful telescope, we're not just looking farther, we're looking deeper into time itself. Each photon that reaches us traveled billions of years to arrive. When it touches our detectors, it collapses a distance between what was and what is. We become witnesses to the universe remembering itself. And yet, even as we capture the faintest glimmers from the edge of creation, we are reminded of our limits. There will always be regions we cannot see, signals we cannot reach, stories we will never know. The horizon of light is the universe's way of reminding us that mystery is not an obstacle. It's part of the design. Maybe the edge of light isn't a boundary at all, but an invitation, a line that says, beyond this, imagination must take over. And beyond that line, perhaps, the universe continues to shine in ways we cannot yet perceive. Because the end of light is not the end of illumination. It's the beginning of wonder. The signal beyond the stars. For centuries, humanity has looked to the night sky and wondered, are we alone? The question is ancient, yet still unanswered. Every new telescope, every mission, every data stream is another attempt to listen, to catch a whisper from the dark. And while we've found no conclusive proof of alien intelligence, we've heard something else. A hum, a rhythm, a series of signals that seem to come from nowhere and everywhere. It began quietly. In the 1960s, radio astronomers detected mysterious pulses from deep space, rapid, perfectly timed bursts of energy. At first, they thought it might be artificial. The first discovery was even jokingly labeled LGM-1, short for Little Green Men. But those signals turned out to be pulsars, the rotating remnants of dead stars, the first cosmic imposters. Still, they taught us something vital, that the universe speaks in patterns, and we must learn its language before we can recognize another voice. Since then, the listening has never stopped. The SETI program, Search for Extraterrestrial Intelligence, has spent decades scanning the skies, sweeping billions of radio frequencies for anything that breaks the natural noise of the cosmos. Amid the static, a few moments have stood out. The most famous is the WOW signal, detected in 1977, a powerful burst that lasted just 72 seconds, unlike anything recorded before or since. It came from the constellation Sagittarius, and then it was gone. No one has ever heard it again. Some believe it was a passing comet, others a technical glitch, and others still, something deliberate. The truth remains elusive, but that uncertainty is what keeps us listening. Today, our search has grown far more sophisticated. New telescopes can analyze thousands of stars simultaneously, searching not just for radio bursts, but for technosignatures, traces of technology that might reveal distant civilizations. Lasers, atmospheric pollutants, artificial satellites, or planetary energy grids all could leave fingerprints in starlight. And already we've found hints of anomalies, unexplained dimming of stars, irregular heat patterns, emissions that defy expectation. One of the most famous is Tabby's star, whose brightness dips in strange, uneven intervals. Some speculated it could be surrounded by a Dyson sphere, a megastructure built to harvest energy from its star. Though natural explanations are more likely, the fact that we can even imagine such structures speaks volumes about our evolution as observers. We're not just looking for life, we're looking for intelligence that builds, shapes, and transforms. And then there are the fast radio bursts, FRBs, flashes of radio energy lasting only milliseconds, coming from billions of light years away. Some repeat, others do not. Their origins remain mysterious. Magnetars, collapsing stars, even the echoes of alien communication have been proposed. Each detection deepens the question, who or what is out there sending signals that cross galaxies? But perhaps the most profound realization is this: if another civilization is looking too, their telescopes might already be seeing us. Earth has been broadcasting unintentionally for nearly a century. Every radio show, every television signal, every radar ping expanding outward in a growing sphere of information. Somewhere, light years away, our first broadcasts are just now arriving, whispering into alien skies, "We are here." Maybe one day, a response will come. Faint, deliberate, unmistakable. Or maybe the signal will never arrive, because we're already part of something larger, a universe that communicates not through words, but through the shared structure of its laws. In that sense, the cosmos has always been speaking to us. Every photon, every gravitational wave, every rhythm of orbit and pulse is a message written in the only language that never fades, existence itself. And when we finally understand it, when we realize the universe has been talking all along, we'll know that the greatest signal beyond the stars was never a transmission. It was the simple fact that we learned to listen. The time before time. Every story we tell about the universe begins with a single moment, the Big Bang. A blinding flash of creation, the birth of space, time, and everything we know. But like every beginning, it hides a deeper question. What came before? For decades, scientists avoided that question. Not because they lacked imagination, but because the laws of physics seemed to break down at the first instant of existence. Time itself began at that point, or so we thought. To ask what happened before the Big Bang was to ask what lies north of the North Pole. It made no sense. Yet the more we learn, the less certain that seems. Quantum cosmology suggests that the Big Bang wasn't a singular explosion, but a transition, a shift in the fabric of reality. Before space and time, there may have been something else, a sea of pure potential, where particles blinked in and out of existence in a timeless quantum foam. In that realm, cause and effect lose meaning. Time, as we understand it, didn't flow. It fluctuated. The universe could have emerged not from nothing, but from a spontaneous reorganization of that eternal chaos. Another theory, the cyclic universe, proposes that the cosmos is eternal, endlessly expanding and contracting in vast cosmic cycles. Each Big Bang is not a beginning, but a rebirth. The universe dies, collapses, and ignites again, carrying within it the faint memory of all that came before. If this is true, then everything we see, galaxies, stars, even ourselves, has existed before, in countless variations, across infinite ages. In this vision, time doesn't begin or end. It breathes. It pulses. It folds in on itself like waves on an infinite ocean. Some models even suggest that our universe might have been born from another, that beyond the Big Bang lies a parent cosmos, and that universes can give birth to new ones through black holes. Each black hole in our universe could, in theory, spawn a new cosmos beyond its event horizon, where physical laws reset and new forms of matter emerge. If so, creation is recursive, universes giving rise to universes, endlessly. The multiverse would not just be a collection of realities. It would be a family tree of cosmic evolution. Others imagine a different kind of origin, one where consciousness plays a role. If time and space are emergent phenomena, then perhaps awareness itself is more fundamental. Some physicists propose that the universe exists in a superposition of states until observation collapses it into form. Could it be that reality only crystallized because it was seen? Because in some unfathomable sense, it wanted to be known? If so, the Big Bang may not have been an explosion of matter, but of perception. The birth of the universe might also have been the birth of awareness. And still, the question lingers, why is there something rather than nothing? If nothing is the natural state, why should anything exist at all? Perhaps the answer is that nothing is impossible. Even the absence of everything contains the potential for something. In quantum mechanics, the vacuum itself seethes with activity, a storm of fluctuations that can spontaneously create particles, energy, even entire universes. In that sense, there was never truly a before. There was only the possibility of being, waiting to awaken. The Big Bang, then, might not be a beginning. It might be a moment of recognition. The instant when potential became aware of itself. When existence, for the first time, looked inward and said, I am. And perhaps, somewhere beyond our reach, new universes are still being born. Each a different version of that same awakening, echoing endlessly through the silence that came before time began. The universe that dreams itself. When we gaze into the cosmos, we often imagine ourselves as small, observers standing at the edge of something vast and indifferent. But what if that perspective is backward? What if the universe isn't something we are in, but something that is in us? What if consciousness is not a product of matter, but the very fabric that allows matter to exist? Modern physics and ancient philosophy now circle the same mystery, the link between awareness and reality. The universe behaves differently when observed. Particles shift from waves of probability into definite states, as though recognition itself shapes existence. It's one of the strangest discoveries in science, and one that hints at a truth far larger than we can easily grasp. Some physicists believe that consciousness might not be an accident of evolution, but a fundamental feature of the universe, as essential as space, time, or energy. This view, known as panpsychism, suggests that everything in existence, from stars to electrons, possesses a spark of experience, however faint. Matter is not lifeless. It is alive in ways we cannot perceive. The cosmos, then, is not a machine. It's a mind. If that sounds poetic, it's because it is, and perhaps reality itself is written in poetry. Each atom, each quantum field, each galaxy could be a neuron in a universal consciousness, thinking and dreaming across the vastness of space-time. We, as conscious beings, are part of that thought, the universe becoming aware of itself through our eyes, our senses, our questions. Simulation theory offers another reflection of the same idea, that the universe behaves like an information system, governed by mathematical rules, capable of self-reference and complexity. Whether it's a simulation or not, the resemblance suggests that reality is structured like a computation, a process that observes itself. Consciousness, in this sense, is not an anomaly. It's the goal. Even the brain mirrors the cosmos. The networks of neurons within our skulls resemble the cosmic web of galaxies stretching across billions of light years. Both systems organize themselves through balance, tension and connection, expansion and collapse. It's as though the same design principle repeats itself at every scale, from the microscopic to the cosmic. Could this similarity be coincidence, or a clue that both the mind and the universe are expressions of the same underlying intelligence? Some mystics and philosophers have long said that the universe dreams through us, that every thought, every act of creation, every story we tell is a fragment of that dream. When we imagine, when we love, when we reach toward the unknown, We are participating in the same process that birthed galaxies. We are not separate from it. We are its continuation. And if that's true, then perhaps consciousness doesn't end when the body dies, just as the wave doesn't end when it merges back into the ocean. Awareness may not be confined to life at all. It may be the ocean itself, infinite, timeless, and self-renewing. When we look at the universe and wonder what it means, we're not asking a question from the outside. We are the question, and we are the answer. The stars we gaze upon are the universe's eyes, looking back at itself through us. Perhaps that's why, despite our insignificance in scale, we feel so deeply connected to everything. Why beauty moves us, why mystery pulls at our hearts. Because the dreamer and the dream are one. The universe dreams itself into being, and in doing so, creates the miracle of awareness. And maybe, when that dream ends, when the last star fades and the final thought dissolves into stillness, the dreamer will awaken once more and begin again. When the stars forget to shine. Every story of creation carries within it the shadow of an ending. Even the stars, those eternal symbols of light, have lifespans. They are born, they burn, and eventually they fade. But what happens when all of them are gone? What does the universe become when the stars forget to shine? Astronomers call it the heat death, the final act of cosmic time. In this distant future, trillions of years from now, the stars will exhaust their fuel and die. The galaxies will drift apart, their light red-shifted into invisibility. The night sky will go dark. What remains will be a universe of fading embers, white dwarfs cooling into black spheres, neutron stars slowing their spin, black holes consuming what little remains of matter, and even those black holes will not last forever. Over unimaginable timescales, they too will dissolve through a process called Hawking radiation, releasing their energy into space until they vanish completely. When that happens, the universe will reach a state of perfect equilibrium. No energy left to use, no structure left to change. A vast, cold silence. Time itself will lose meaning, because nothing new will ever happen again. It's the bleakest vision science has ever proposed. Yet in that silence, there is also a strange kind of peace. The universe will not end in fire or violence, but in stillness, a long exhale after eons of creation. Some physicists believe that even this may not be the end. Quantum fluctuations, the same kind that may have sparked the Big Bang, could eventually give rise to new pockets of energy, new universes budding out of the ashes of the old. If that's true, then the death of our cosmos may simply be the seed of another, a cycle of creation and dissolution that never truly stops. Others imagine a more haunting scenario, that consciousness itself might be the last survivor. Long after the stars fade, artificial or collective intelligences could endure in simulated realities, powered by the faint remnants of energy scattered through space. These entities, if they exist, might preserve memory itself, holding on to the story of the cosmos long after its light has gone out. And yet, perhaps this ending is not meant to be feared. The fading of the stars is not the failure of the universe. It is the completion of its arc, the inevitable stillness after motion, the rest after infinite creation. Even the darkness will carry the memory of light, encoded in the background radiation, in the geometry of space-time, in the quiet hum of existence itself. From one perspective, it's an ending. From another, it's a transformation. Energy never truly disappears. It changes form. Matter becomes dust. Dust becomes thought. Thought becomes silence. And silence, perhaps, becomes the beginning again. So maybe, when the last photon flickers out and the last atom decays, the universe won't die. It will simply return to what it always was. Pure potential. Waiting, once more, for the spark of awareness to awaken. And when it does, everything, the galaxies, the stars, the oceans, the lives, will rise again. Not as they were, but as they have always been. One endless reflection of the infinite. The universe began in darkness, and it will end in darkness. But between those two silences, it created light. And in that brief, luminous moment, it learned to see itself. the infinite horizon. At the edge of everything we know, beyond the last glimmer of starlight and the farthest reach of thought, lies a horizon that never ends. The infinite horizon, not a place, but a realization. The understanding that the universe was never a journey outward, but inward. That the farther we search through space and time, the closer we come to discovering ourselves. For all our instruments, all our mathematics, all our stories, we've only ever been describing reflections, light scattered through consciousness, meaning drawn from mystery. The cosmos is not out there waiting to be found. It has always been within us, mirrored in the structure of our minds, encoded in the rhythm of our hearts. Every breath, every heartbeat is a small echo of cosmic creation, expansion and contraction, existence and return. When we gaze upon the night sky, we are not looking into the past. We are witnessing eternity, captured in motion. The light we see began its journey billions of years ago, yet it arrives now, in this moment, as though time itself were folding to meet us. The stars may seem distant, but their photons touch our skin. The universe is not something we observe. It's something we participate in. We are the consciousness of the cosmos, awakened just long enough to ask, why? And in that question lies the answer. The universe needed to know itself, to perceive its own beauty and fragility, to witness its own infinity through the eyes of life. That is why we are here, not as observers of creation, but as its continuation. When the stars fade and galaxies fall silent, when time itself begins to unravel, awareness will remain, not bound to matter or light, but as the pure recognition that there was something rather than nothing. That existence happened, that it was beautiful. Perhaps eternity is not endless time, but timeless presence. Not an infinite number of years, but a single infinite moment, the one we are living right now. The horizon we chase through science and philosophy may not be a boundary at all, but the mirror of our own perception, reflecting back the infinite within us. Everything we have ever been, and everything we will ever be, still exists in that reflection. The first atoms forged in ancient stars, the first spark of thought in a human mind, the final whisper of energy at the end of time. All of it still here, intertwined in the same endless field of being. The journey was never about reaching the edge of the universe. It was about realizing there is no edge, that every horizon we cross simply expands the circle of what we call home. And when we finally understand that, when we see that the infinite has always been part of us, the search will end, not in discovery, but in recognition. Because the truth was never hidden in the stars. It was written in the silence between them.